Hello, I'm David Presby, President of Presby Environmental and the inventor of the Enviro-Septic Wastewater Treatment System. I hope to leave my mark on this world by providing septic solutions that do a better job of purifying wastewater. Other than oxygen, there is nothing more important to the human health and survival than water. As our population continually grows, the supply of safe drinking water is dwindling. I have made it my mission to protect our limited water resources and preserve them for generations to come. I've worked in the septic industry all my life. My experience designing, installing, pumping, and troubleshooting all types of septic systems led me to invent something better, the Enviro-Septic Wastewater Treatment System. My system is superior to other septic systems because it protects the environment better, it is smaller in size, it is less expensive to construct and maintain, it is easier to design and install, and it lasts longer. Let me tell you what's different about the Enviro-Septic system, how it works, and why it's a better choice. The widespread use of conventional pipe and stone septic systems over the past 100 years has created the false impression that they are safe for the environment. Actually, they do nothing more than release untreated wastewater into the soil. The size and the expense of stone systems led to the development of alternatives, such as plastic chambers and products that incorporate fabric to increase surface area. The glass on the right is effluent from the outlet of a septic tank. It contains suspended solids that make it darker in color. As these particles collect on the soil or the fabric surfaces of other systems, a clogging layer forms that restricts the flow of wastewater. This layer also cuts off the oxygen supply. As wastewater passes through a pipe and stone system and gets to the interface between the stone and the soil, the suspended solids cannot pass into the soil. Instead, they accumulate on top of the surface of the soil. Over time, suspended solids clog the receiving surface of the soils more and more. This process is referred to as progressive failure. In the systems that use fabric, the clogging layer forms on the fabric. The clogging layer that develops in other septic systems leads to an oxygen-starved environment that reduces treatment. When this layer becomes as thick as 2 sheets of paper, it is enough to greatly reduce the treatment from lack of oxygen. As the clogging layer grows, the bacterial activity becomes less effective, and the system eventually clogs, no longer allowing wastewater to pass through, forcing it to back up or to break out on the surface, creating a health hazard. Since all of these systems fail for the same reason, it became obvious that there was a need to protect the bacterial receiving surface from suspended solids in order to improve treatment and to extend the life of the system. I set out to invent a product that would prevent the clogging of the receiving surface by retaining the suspended solids within the system while ensuring an adequate supply of oxygen to maximize the effectiveness of the beneficial bacteria. The result is the Enviro-Septic Wastewater Treatment System. The oxygen-enriched environment created by the Enviro-Septic system makes bacteria more effective at purifying wastewater. By providing a protected receiving surface, a microscopic bacterial treatment layer forms. It remains permeable, allowing oxygen to get to the bacteria, treating wastewater as it passes through. Since the receiving surface does not clog, the Enviro-Septic system will last significantly longer than other systems. Let's look at the different parts that make up the Enviro-Septic system. First, we see the inner pipe. It is made from high-density plastic, including a significant amount of recycled plastic. It is strong, but lightweight, and flexible enough to be bent to 90 degrees. It comes in 10-foot lengths, but is easily cut to any length. The pipe's patented ridges add surface area for bacterial growth, utilize ground temperature to cool the effluent. Perforations in the valleys of the pipe allow effluent to pass through. At each hole, a skimmer tab extends into the pipe. The function of these skimmer tabs is to retain the suspended solids inside the pipe. Around the pipe is a layer of coarse plastic fibers. These fibers strip out the suspended solids and provide a tremendous amount of surface area for bacterial growth. The outside layer is a non-woven geotextile fabric. This fabric is stitched to keep it in place. A protected microscopic bacterial surface forms on the inside of this fabric and remains permeable. Another difference to note is the tremendous amount of surface area created by the different materials that make up the Enviro-Septic pipe. This is important because all of this available surface area has the potential to become populated with beneficial bacteria. In every 1 foot of Enviro-Septic pipe, there is approximately 24 square feet of available surface area. Let's look at what takes place in the Enviro-Septic system. First, warm effluent enters the pipe from the septic tank and is cooled to ground temperature. This cooling causes suspended solids to separate into scum and sludge layers within the pipe. Skimmer tabs capture scum from the effluent, retaining this material inside the pipe in order to prevent clogging. As effluent travels through, the coarse fibers collect more suspended solids. The inside of the geotextile fabric develops a protected microscopic bacterial surface, treating the effluent as it passes through. The system sand that surrounds the pipe wicks the treated water away from the system and into the underlying soil. An ample air supply and fluctuating liquid levels increase the bacterial efficiency. Enviro-Septic is designed to create a balanced ecosystem which quickly becomes populated with beneficial bacteria. This perfect environment enables bacteria to carry out the natural processes that are highly effective at removing contaminants from wastewater. Here we see the inside of the Enviro-Septic system in use. The skimmer tabs are capturing the suspended solids so they do not pass out through the holes in the pipe, allowing them to be collected inside the pipe, preventing clogging. Some people ask me, doesn't the pipe get filled up with all these suspended solids? The answer is, not in your lifetime, and probably not in your children's lifetime either. There is enough storage capacity in just one 10-foot section of Enviro-Septic pipe to hold more than 7 years of accumulated suspended solids from the average household. A properly designed, installed, maintained Enviro-Septic system has the potential to work indefinitely. This system was inspected after 5 years of use. Note the system sand is still clean. The microscopic bacterial surface is still protected. We can see that the suspended solids have been retained inside the pipe or collected on the coarse plastic fibers. Keeping the suspended solids inside the pipe protects the microscopic bacterial surface and the receiving soil from being clogged. Soil has the ability to accept an unlimited amount of clean water. Our system produces wastewater that has been highly purified. The cleaner the wastewater is, the more the underlying soils can accept. This allows our system to be used in more dense soils. Since it releases cleaner water, the footprint required for an Enviro-Septic system can be as little as 1/4 the size of what is needed for a pipe and stone system. A reserve area for replacement systems is not needed because the underlying soils are preserved. Normally, a system receives sporadic doses of wastewater throughout the day. The remainder of the day, the system is resting. When wastewater flows into the system, the water level in the pipe goes up. When the liquid passes out into the system's sand and soil, the water level inside the pipe goes down. This wet and dry cycling within the pipe has been proven to create an environment in which bacteria thrive. As treated wastewater enters the system sand, it pushes gases out of the void spaces in the sand and into the airspace at the top of the pipes, then out through the venting system. As the treated wastewater passes from the system sand and into the native soil, the void spaces in the system sand are again filled with air, providing oxygen to the bacteria.